ladies and gentlemen, welcome to Dinamalo tutorials. Today we are going to look at Rankine and Carnot efficiency. So we are given a problem here, so we have to solve this problem by calculating the Carnot and the Rankine cycles. So what I'm going to do here is let us read the first question. The question is saying, in a steam power cycle, the steam supply is at 15 bar and dry and saturated. Then the condenser pressure is 0.4 bar. Calculate the Carnot and Rankine efficiencies of the cycle. Neglect pump work. So here you have to first mark the keywords. So the keywords we are having here is this. Here we are having the steam supply. Our steam supply at a pressure of 15, and here we are having also the condenser pressure, which is 0.4. So you have to calculate the Carnot and the Rankine efficiency using the information we are given here. So firstly, you can firstly draw the TS diagram first. So our TS diagram here, we are going to have temperature, and here we are going to have S representing the enthalpy. Then you draw your graph. So here we are going to write 1, and then here we are having 2, 3, 4, 5, and here we are mainly need this line. This line is representing the saturated vapor. This line is representing our saturated vapor. Because on our question we are not having the superheated steam, we are just having the saturated vapor. So this line is just representing the saturated vapor. So this is where we are having what our first saturated vapor here point, meaning to say our P1 is going to be here to this side, and then our P2 is going to be this side. Then here from 3 to 4 we are having our pump then, but the question is saying neglecting the pump work. Then what are we supposed to do now? When we are calculating this Carnot and Rankine efficiency, we have to first put on information on the paper. Then after writing the information, then we start to work out the question. So we are given steam supply pressure, which is our P1, is at 15 bar. But when we are looking at our steam table, we are going to see that our pressure is in kilopascals, meaning to say we have to change this 15 bar to kilopascals so that we'll be able to use this steam table. So here we have to change this 15 bar to kilopascals. So what I'm going to do when we are changing this 15 bar to kilopascals, we are going to multiply this 15 by 10 to the power 5, and then we change this 10 to the power 5 to be 10 to the power 2 times 10 to the power 3, where this 10 to the power 3 is going to represent the kilopascals, and the meaning to say we are going to only multiply this 15 by 10 to the power 2, then 10 to the power 3 is going to represent for the kilopascals. So our answer is going to left as 1500 kilopascals. This is our P1, the steam supply pressure. So on the steam supply pressure, we have to find what we call H1. And then our H1, we know that our H1 is our Hg. So we have to take our steam table, then we have to find 1500 kilopascals. So we are going to see that here we are having 1500 kilopascals here. So we have to find our Hg. So our Hg is equals to 2789.84 kilojoules per kg. Then after that we have also to find S1. So our S1 on the same 1500 kilopascals pressure, we have to take that number at SG. So our SG is 6.4407 kilojoules. So we are done with the pressure one. So let's go on the condenser supply pressure, which is P2, which is equals to 0.4. This is the condenser pressure. So 0.4 bar, you have to change this 0.4 to kilopascals. I'm going to say here, we're going to say 0.4 times 10 to the power 5, and then we change this 10 to the power 5 to be 0.4 times 10 to the power 2 times 10 to the power 3, and then here we are going to only multiply this 0.4 by 10 to the power 2, and then this 10 to the power 3 is going to represent for the kilopascals. I'm going to say, so here we are going to left with 40 kilopascals. This is our P2. Then after that, now we need to find HF2. We have to find HF of this pressure 2. So we have to take our steam table, and then we go straight 140 kilopascals. 140 kilopascals. Then on 40 kilopascals, we have to find HF. So our HF is 317.46 kilojoules per kg. Then we have also to take HFG of this 40. So HFG is 2319.39 kilojoules per kg. Then after that we have to also take the SF2 of this 40. So SF of 40 here, you have to make sure that your ruler is in a straight line, so that you're going to write the correct number. So here we're going to get 1.0252 kilojoules. Then we have also to find SFG2. So SFG2, we're going to take 6.64 kilojoules. So after having this information, now you have to find H2. So for H2, we know that the formula for H2 is HF2 plus X HFG2. And then so when we are using the information we are given here, we are going to say that we are having HF2, and then we don't have X, and then HFG2 we are having it also. So you cannot be able to find this H2 where we are not having X here. So it means we have to find X first. So for you to find X, you have to write the formula S1 is equals to SF2 plus X SFG2. Meaning to say, you have to have this formula in your head, because you are not going to be given the formula book. So now our S1, we are already having it here, 6.4407 equals to SF2. Our SF2 is 1.0252 plus X, then SFG is 6.6450. So our X is going to be, meaning to say here we are going to write 6.4407 subtract by 1.0252. Then our answer, we are going to divide it by 6.6450. So our X is going to be 0.815. So after having this X, now we are able to find H2. So our H2 now, we are going to take HF2. Our HF2 is 317.46 plus x 0.815. HFG, our HFG2 is 2319.39. so now our H2 is going to be, so you have to put this on calculator, 317.46 plus 0.815 multiplying by 2319.39. so now our H2 is 22,207.763 kilojoules per kg. So now after having this information, now you are able to find the Carnot efficiency. So the formula for Carnot, because our question is saying calculate the Carnot efficiency. So our formula for Carnot efficiency is equals to T1 minus T2 over T1. Meaning to say here we have to take our steam table, and then now we are knowing that our pressure 1 is 1500 kilopascals, and then pressure 2 is 40 kilopascals. So you have to, for you to be able to find T1, you have to go to our pressure 1. This pressure 1 is going to help us to get this temperature 1 here. So we are going to go to 1500 kilopascals here, and then we are going to check what temperature are we having here. We are having 198.2 this temperature, then subtract by T2, we are going to come to here to 40 kilopascals. Then on 40 kilopascals, what temperature are we having? We are having 75.89 over T1, it's 198.28. So now this temperature is in degrees Celsius, but the SI for temperature is need to be in Kelvin. So you have to add plus 273 on each value here. Meaning to say you are going to add plus 273 here, plus 273 here, plus 273 here, so that your answer will be in Kelvin. So 198.28 plus 273 minus 75.89 plus 273 all over 198.28 plus 273. So you have to put this on calculator. So we have 198.28 plus 273. What is going to be? We're going to get 471.28. Then we add also 75.89 plus 273. We're going to get 348.89 all over 470.28. So now you have to punch this on calculator. 471.28 subtract by 348.89 over 471.28. So you are going to get 0.259. But when we are writing efficiency, we know that efficiency is written in as a percentage. So you have to multiply our answer by 100%. So when we multiply here by 100%, we are going to get 25.9%, or you can round it to be 26%. So we are done with the Carnot efficiency. So now we are moving to the Rankine efficiency. So when we are working out the Rankine efficiency is written as this. So we know that the formula for Rankine efficiency is H1 minus H2 over H1 minus HF2. So we are going to look on this paper where we are writing our information. So we are going to write what is our H1 here. Our H1 here is 2789.84. Then we subtract it by H2, which is 2207.763, over our H1 2789.84 minus HF2. HF2 here we are going to just take it here, which is 317.46. So now I'm going to say 2789.84 subtract by 2207.763 divided by 2789.84 subtract by 317.46. Then our final answer is going to be 0.235. But as I've said earlier, that when we are writing our units, we have to multiply our answer by what? Our efficiency, you have to multiply it by 100%. So our answer is going to be 23.5%, or we can just round it, then write 24%. Thank you.